Think about a sports coach during a game, constantly monitoring the player's energy, subbing out the exhausted ones, and adjusting strategies based on real time data. I remember reading about Germany's win in the 2014 World Cup, where data science helped the coaches decide on a late substitution of the fresh Mario Götze, who scored his iconic World Cup winning goal. Now, what if businesses could do the same with their workers? Imagine knowing exactly when someone is hitting their fatigue limit and preventing accidents before they happen. In this video, I'll explain how cutting-edge technologies like machine learning and geospatial intelligence bring this level of game time decision-making to the workplace. Recently, I reviewed a fascinating study conducted in one of DENSO Corporation's factories. They're an automotive parts manufacturer in Japan. The goal was to understand how heat and physical activity impact worker safety and productivity, particularly in high-temperature environments. The research team used a combination of Bluetooth beacons and environmental sensors to track worker locations, monitor environmental conditions like temperature and humidity, and assess physical load. What they found could change how we approach workforce safety in factories and all labor-intensive industries, especially those in extreme climates. A simple measure of measuring the temperature at a fixed point didn't cut it for this study. Instead, by tracking each worker's location throughout their shift and combining it with the environmental sensor data, the researchers developed a much more comprehensive and accurate understanding of how heat affects each individual. They used regression models to predict the thermal comfort and decision tree models to pinpoint critical factors contributing to worker fatigue. Day shift workers felt significantly hotter than their night shift colleagues, mainly because of air temperature. This finding is important because worker fatigue isn't just a nuisance. It's the leading cause of accidents, mistakes, and productivity loss. By accurately predicting when workers are their most tired or uncomfortable, businesses can reduce risks before they lead to costly errors or dangerous situations. This is where machine learning can help us a lot. As a specialist in AI and machine learning, I can tell you that this study is just scratching the surface of what's possible. We could take these findings to an entirely new level with the right machine learning extensions. Let me walk you through some of the possibilities. We can use machine learning to develop personalized models instead of a general one for all workers. Think of it like Netflix recommendations, but for worker safety. Each worker's unique characteristics, such as their fitness level, the type of tasks they perform, and even their hydration habits, could be used to predict when they'll need a break or cooler workspace. Using filtering, much like in a recommendation system, we could customize heat management strategies in real time, optimizing both productivity and worker safety. We can also apply time series forecasting models like LSTMs or ARIMA to predict when a worker will hit their peak fatigue based on temperature, activity, and workload patterns. These models are great at recognizing patterns in data that change over time. These patterns allow us to make accurate future predictions. This could allow businesses to proactively adjust shifts, workloads, or cooling systems before the heat stress becomes an issue. Another powerful application is anomaly detection. We could train machine learning models to detect abnormal conditions, like a sudden spike in temperature or a worker's activity suddenly dropping off, which might indicate early signs of heat exhaustion. Using techniques like autoencoders or isolation forests, these models can automatically flag when something seems off, alerting supervisors to step in before a problem escalates. Machine learning-based anomaly detection is essential in many different fields for applications like detecting credit card fraud, abnormal health conditions in patients, or illegal activities from satellite data, because it can identify when something doesn't fit the standard patterns of human behavior. Then there's the potential of reinforcement learning to optimize working conditions in real time. Imagine an AI system that learns the best ventilation, cooling, and break times to keep workers comfortable and productive throughout their shifts. This system could automatically adjust based on real-time sensor data, ensuring no worker stays in a high-risk zone for a long time. Another example that I'm very familiar with is fusing external environmental data, such as weather forecasts or air quality, into the model. A multimodal deep learning model could predict how outdoor conditions impact indoor environments, enabling factories in regions like the Middle East or Southwest US to take preemptive action to mitigate heat stress. While working with the WHO, I successfully fused environmental data with disease case data to predict outbreaks, utilizing machine learning to uncover factors affecting public health. This experience aligns with extending the current study by integrating environmental data with worker safety metrics, making me well qualified to implement advanced machine learning solutions to optimize workplace health and safety. Tracking workers' health and activity through real-time data, such as energy levels, fatigue, and heat exposure, raises significant privacy concerns. Monitoring individuals so closely could lead to an invasion of personal space, a sense of constant surveillance, and misuse of data by employers, potentially impacting job security or worker autonomy. If not managed carefully, this technology might create a culture of distrust, where workers feel more like monitored subjects than valued employees. To address these concerns, companies should prioritize transparency and data privacy by clearly communicating the purpose of monitoring and how the employer uses the data. Implementing strict data anonymization and security protocols will protect workers' personal information, involving workers in the decision-making process, setting clear boundaries on the type of data collected, and focusing on safety and well-being rather than performance micromanagement are critical steps to foster trust and avoid potential negative impacts. I've been working in this area for over 20 years. I've seen firsthand how powerful these AI tools can be. From using satellite data to predict disease outbreaks across Africa, to developing systems that detect oil spills in the Arabian Gulf, I've built AI solutions that don't just analyze data, they provide actionable insights that decision makers can rely on. I focus on bringing these advanced AI techniques to industries and governments that need real-time, data-driven solutions. In environments like the one in this study, where heat is a constant challenge and worker safety is at stake, the ability to predict, prevent, and optimize can be a game changer. So if you're a decision maker in government, an international organization, or a business that manages labor-intensive workforces, especially in hot climates, let's talk. We can build systems that keep workers safe and boost productivity and efficiency. I'm ready to partner with you to implement advanced machine learning and geospatial intelligence solutions to make your operations smarter and safer. Whether you're interested in implementing these AI systems, optimizing worker safety, or transforming your data into actionable insights, I'm here to help. Let's create solutions that work for you and those who rely on you. Thank you so much.